All right, so section 5.2 continues the probability topic. So these are really short sections, so that's why we're doing 2 in one day. But section 5.2 is the addition rule and the rule of complements. Okay. So we're going to begin to look at compound events, which are basically just like they sound, more than one event occurring at the same time. So it's an event formed by combining 2 or more events. And so one way to think about that is we can talk about the probability of A or B. Remember, this is our notation, right? Capital P means probability of. So probability of A or B basically means the probability that A occurs or B occurs or both occur. Okay, so or means one or the other or both. Okay. And so sometimes we will look at our data kind of organized in a table, and this is called a contingency table. My Y kind of looks connected to my C there, so let's fix that. And so a contingency table is just basically categorizes the different events into a table. So a lot of the times we're going to see our data presented to us in this way, and it's just a good way to organize it, and then we can answer questions based on it. So let's consider the following contingency table. So let's say that 1,000 adults are surveyed. And asked if they support the passing of some new law. Or did they support it in the last election? Okay. And so we're going to set up kind of a couple scenarios. So skip a little space, like maybe a line. So we're going to split up these people into likely to vote and not likely to vote. But then we're also going to track whether they favor this new law, whether they oppose it, or whether they're just not sure yet. They're undecided. So use your notebook paper to make pretty lines, prettier than the ones I'm making. But we're going to list all the people in these categories. And then let's say that we have the following quantities of people in each of these categories. Okay, so you can always pause this and kind of catch up on the contingency table if you'd like to. But I'm going to proceed with the questions from it. So the probability that a person is likely to vote, okay? Because, by the way, the reason we're probably tracking this is it doesn't necessarily matter how many people oppose it if they're not going to vote anyway, right? So, honestly, these 103 people here, if you're for the law, you're not too concerned about them, right? Because they oppose it, but they're not going to vote anyway, so they kind of don't get a real opinion, right? Kind of like everybody always says. So the probability that they're likely to vote. So notice likely to vote is this row here, this horizontal row. So we just need to add up the whole first row, and that'll be all the likely to vote people, and then we'll put it over. Notice if you come back up to the beginning, I went ahead and told you the total, but if I didn't give you the total, you could just add all these quantities in the chart, right, or in the table. So we're going to put that over the 1,000 total people, and so we're going to get a decimal of 0.721. Okay, I think a lot of times on your Connect homework, it's just going to ask you for a decimal. If it asks you for a percentage, of course, that would be 72.1% because you'd move the decimal twice. All right, so let's look at the probability of someone favoring the rule or the law. Okay, so notice favor is this column here, right? The vertical column. So you would take the 372 people plus the 151, and you would put that over 1,000. Okay, and if you add that up and divide by 1,000, you'll get 0.523. So 52.3%. Okay. Remember that you always should get probabilities between 0 and 1, and if you don't, something's wrong. You cannot have a probability less than 0 or more than 1. So what about the probability that they're likely to vote and they favor the law? Okay, now we haven't really talked about and before, but I think we can figure it out, right? It means that it needs to be in both categories, right? So notice that is only this group of people, right? Only the 372. So it would be 372 still out of 1,000. And so that works out to be 37.2% or 0.372. All right, so we're going to come back to this example in just a minute, but I'm going to put a star by this because this is a formula / concept you need to know. So for events A and B, okay, the probability of A or B occurring is going to be the probability of the first thing plus the probability of the second thing. But then you've got to subtract off the probability that it is both. Okay, so for now, just write down this formula and then we're going to use our previous example to talk about it. But the reason we're going to subtract off this amount at the end is because it would avoid counting certain categories twice. Okay. Because if you think about it, if you went up here and took the previous example and you tried to just add the number of people that were likely to vote, which is all this row of people, right? And then you tried to add all the people that were favoring the law, which is this column of people, then you're counting this 372 people in both categories, right? Because they're both likely to vote and they favor the new law. So if we want to avoid that, so for example, one above, if we want the probability that they are going to vote or that they favor the new law, right, we would need to take the probability that they are going to vote plus the probability that we favor or that they favor the law, but then you would need to minus the probability that they're in both categories, right? So probability that they vote, that they plan to vote and that they're in favor. So we'll just do this in fraction form, but then I think you'll see you could probably combine it as one fraction if you wanted to. So the probability that they voted, we already got 721 out of 1,000 there. Part B, the probability that they favored was 523 out of 1,000. Notice I'm using the fraction forms. We'll talk about that in a minute. But then I need to subtract off the probability that they're in both categories so that I don't count that group of people or those items twice. Notice when you add and subtract fractions, the denominator stays the same. So all you're really doing is adding and subtracting the numerators. So if you do that, you'll get 872, which is 0.872. So 87.2% either plan to vote or favor the law or both. Okay, so let's see if we can, again, use example 2 above. So what is the probability that they are not likely to vote or undecided? So using the same contingency table, let's see if we can figure out the chance that they're not likely to vote or they're undecided. So this is going to be the probability, I'm going to abbreviate this, the probability that they're not going to vote plus the probability that they're undecided, but then don't forget to minus the probability that it is both. Okay. So let's figure out what that is, and I'm going to kind of do this all at once. So the probability, I'm going to slide this paper up. The probability that they are not likely to vote, okay, would be this whole row here, right? So let me, try to move that over. So the probability that they're not likely to vote would be 151 plus 103 plus 25 out of 1,000, right? This is just the probability that they are not likely to vote. And then we need to add that to the probability that they're undecided. Notice that's this column, right? This vertical column. So that's 87 plus 25 more. But then if I don't do the last thing, then I'm going to be counting these 25 people twice, right? I'm counting it in this row, but I'm also counting it in this column, and I don't want to count those people twice. So I just subtract off 25 out of 1,000. And again, the denominator stays the same. I really just need to work on what the numerator would be. Okay, so if you work all of that out, you end up getting 366 out of 1,000, which is 0.366. Okay. If you have denominators or totals that are like 1,000 or 100 or something like that, it's often really easy to try to figure out what the percentage is, but if not, you just use your calculator. So like if it would have been like 366 out of 600 people, then that's not a decimal you would probably be able to come up with without using a calculator. So you would just do 366 divided by 600 to get your answer. Okay, so one of the terms when we're talking about conditional probability or, event probability is whether or not the events are mutually exclusive or not. And so these are two events that cannot occur together. So think of it like if you are mutually exclusively dating somebody, that means you are not going to date anyone else, right? So you cannot have two events or two significant others, okay? So mutually exclusive literally means that they would not be able to happen together. So an example of mutually exclusive would be heads and tails, right? You can't be both heads and tails in the same flip, right? The coin is going to land either on heads and tails. It can't land on both. So let's do a little more complicated. But let's say we roll a die. Okay, so a die is the singular form of dice. Dice is more than one, but die is one. And so let's say event A is we're going to roll a 3, or we want to roll a 3 for whatever reason. And then B is going to be rolling an even number. So unless I tell you otherwise, we're talking about a normal die, like a 6-sided dice, 1, 2, 3, 4, 5, 6. Okay, there are dies that have more sides, but if I'm talking about one of those, I'll mention that. Okay. Notice that events A and B are mutually exclusive. And the reason they're mutually exclusive is because a number won't be both a 3 and an even number. Like it's impossible, right? Because 3 is not even. Okay, so they're mutually exclusive because both cannot occur in a single roll. Notice that if it were rolling, if event A was rolling a 2 and event B was rolling an even number, then those would not be mutually exclusive, right? Because those could occur together. You could roll a 2, which would also be an even number. But in this case, a 3 is not even, so both can't occur at the same time. Okay, so let's look at maybe another usage of the term mutually exclusive. So let's say next year, one of your college classmates are chosen at random. And event A is that the student is older than 21. And let's say that event B is that the student is taking a stats class of some kind. And so my question is, are events A and B mutually exclusive? So what I'm really asking you, remember, mutually exclusive means that they cannot, under any circumstances, occur together. Okay? And so the question really is, could they be a student that's older than 21 and still be taking stats? And the answer is that both of those things could happen, right? So no, they're not mutually exclusive because both events could occur at the same time. A student could be older than 21 and taking statistics. Okay, so they're not mutually exclusive. It means they can occur together. So when you are sure, though, that the mutually exclusive, or when you're sure that two events you're referring to are mutually exclusive, I spelled mutually wrong. So for mutually exclusive events A and B, and this is only when you're sure that they can't occur together, we can simplify the addition rule. So remember how we said that the probability of A or B was the probability of A plus the probability of B minus the probability of both? Well, if you're sure that they are in fact mutually exclusive or that they can't occur together, then all you have to do is add the probability of A and the probability of B together. And think about why that is, though. It's because you don't need to subtract off the probability of both, because that can't happen, and so this part that would normally be here would have a probability of 0. Okay, that's why you're allowed to drop it. Okay, that's why you don't really need to subtract off the probability of both, since it would be a probability of 0. Okay, you don't really need to write that. I'm just trying to explain why it is the way that it is. Okay, so let's do an example. So let's let E be the event that a new car needs engine work, and T be the event that a new car needs transmission work. So E for engine work, T for transmission work. And then let's say you're given the following probabilities. Let's say the probability of engine work is 0.10. The probability of transmission work is 0.02. And the probability that the car needs both is 0.01. Okay, so given these probabilities, let's find the following results. So I want you to find the probability a car needs work on the engine, transmission, or both Okay. So when I ask you for the probability that a car needs engine work, transmission, or both, note that that, by very definition, is E or T, because that's what or means. It means one or the other or both. Okay. So then I just need to use the formula. By the way, so the question is, can I use the simplified formula or not? And notice the answer to that is I can't, right? Because they can occur together. So I'm going to need to use the longer formula. So it's the probability of the first plus the probability of the second minus the probability of both. And notice I have all of those things given to me, right? The probability of engine work is 0.10. The probability of transmission work is 0.02. The probability that it is both is 0.01. So remember, this avoids something being counted twice. So this is 10 plus 2, which is 12, minus 1, which is 11. So the probability is 0.11. Okay. So this isn't a tough question, but I want you to think about why it's true or not. Are events E and T mutually exclusive then? So in other words, was there an option of both occurring at the same time? Okay. And notice that the very existence of this means that they can occur together, right? It's not a very big chance, but it's a 1% chance, but it's still there, okay? So they are not mutually exclusive since both can happen together. Okay, and we know that because the probability of E and T was 0.01. Okay, the only way you would be able to say yes, they're mutually exclusive would have been if that probability of them both occurring would have been 0. Okay, so the last term in this section is complement. So the complement of an event means the event doesn't occur. Notice it's not spelled like compliment, like if you're giving someone a compliment on their outfit or their hair today. Okay, so complement is with an E. And so the notation for that is going to be, you'll have the event A and then you'll have like a little c up here. It's not really an exponent, it's just C for complement. So when you see A with a little c up there, it means not A. And often it's going to be easiest to figure out the probability that something doesn't happen by doing the opposite. In other words, if you just subtract the probability that the event does occur from 1, okay, because remember 1 in decimal form just means 100% in percentage form. Okay, so sometimes it's easier to figure out the probability that an event doesn't happen by just doing 1 minus the probability that it does. Okay, so let's take that logic. So for example 3 above, I want you to find the probability that a random car needs no engine work. Okay. So notice I didn't really give you the probability that it needs no engine work, right? But I did give you the probability that it does need engine work. So first of all, notation-wise, we would call that the probability of no engine work, right? Or not engine work, however you want to say it. So we would just do 1 minus the probability that it did need engine work, which if you go back up and look at example 3, the probability of E was 10% or 0.10. And so the probability that the car doesn't need engine work at all would be 90%. Okay, so note, even though we weren't given that percentage, we can just subtract it from 1 pretty easily to find that probability. Okay, so let's do an example of some of that, and let's do another contingency table. So let's say that we have 23 or 25 students in a class, and a lot of them are sick. This is obviously pre-COVID because now if they're sick, they'll get sent home immediately. So again, skip a line so that you can fit this whole chart. But let's say we've got some kids with the symptom of a runny nose. And then we've got some that have the symptom of a sore throat. But then, of course, we have kids that, don't have these symptoms, so you have to have the no option also for both. Okay, so there's 25 students in class, and let's say they kind of pan out like this. So this is the breakdown of the class of 25 kids. Some are sick and some are not. Okay, so first, let's find the probability of runny nose. So the first thing is, the easy part is we know it's going to be over 25, right? Because there's 25 students. Okay, also, if you didn't know that, you could add them up, just like before. So the runny nose people are this one and this one, right? So we're going to add those up. And so we've got 18 over 25, or 0.72. Okay. By the way, in probability, when we are saying the answer is exact, let's use an equal sign, and when we're rounding it, we're going to use that squiggly equal sign to indicate that our answer is not exact. But this one actually is exact because 25 is a pretty nice round number to divide by. So what about the probability of sore throat? So if you look up at the chart, notice sore throat is the column, right? So you would do 6 plus 4, but again, it's over 25. So you end up getting 10 over 25, which is 0.4 or 40%. But then what if I asked you for the probability of a runny nose or a sore throat? Okay. So notice that would mean that I would need the probability of runny nose, probability of the first thing, plus the probability of the second thing, minus the probability of both. Okay, because notice there are some people in the both category, right? These 6 students are in the both category, so we do need to kind of consider that. So let's figure out what we get. So the probability of runny nose, and by the way, if you round the decimals especially, I don't want you using decimals in this formula. Make sure you go back and use the fractions, the unrounded fractions. In this case, it doesn't matter because the decimals came out pleasantly, but it will matter in your homework if you're adding rounded decimals kind of as you go. You want to round only at the end of the problem, especially in stats. So we're going to use the fractions. But 18 out of 25 had the runny nose. 10 out of 25 had the sore throat. And then if you look up here, there were 6 students that have both symptoms. So again, when you add and subtract fractions, you have to have a common denominator, and that stays the same. And then you just add and subtract the top. So this would be 28, take away 6, or 22. Okay, so this would be, this rounds out, not rounds out, this comes out to be exactly 88%, or 0.88. Okay. By the way, notice if you did not subtract off, you would have 28 over 25, which is going to give you a number more than 1. And we've already mentioned it, but you should never get a probability less than 0 or more than 1. 1 means it's certain to happen, and you can't get any more certain than that, basically. Okay. And then lastly, what's the probability that they have neither symptom? Okay. And so you could do, you could just use the complement rule. So notice this is the probability that they're sick in some way, right? The probability of runny nose or sore throat. So you could do 1 minus the 22 over 25, or the 0.88, and that would give you 0.12. Okay. Or in this case, it might be easier just to go up to the chart and notice that there are 3 students that are in the no category for both, right? So notice if you do 3 out of 25, though, you also get 0.12. Okay. So really, I don't care which method that you use to find it, but just know that sometimes you're going to want to use this complement rule, so that's kind of why I mentioned it there. Okay. So this is just kind of a snippet, a little starting of probability. So in the next class, we're going to get more and more in depth into probability. So you really want to make sure that you understand how to find basic probabilities, and then now how to find something or something else. Okay, and definitely make sure that you understand the concept of mutually exclusive. Okay. All right, and just like I said in the email, remember you're supposed to take notes and you're supposed to send those to me. Okay, so take notes from both sections and then send me either a quick video of you flipping through it or just multiple pages if you can't send a video.